Morning, everybody. In this video, I'm going to show you all the equations you need to do the 3 practice problems of the day. I'm also going to do one of the practice problems with you. So after this, you'll have 2 more to do by yourself. Here's the 4 equations from yesterday. As a reminder, P is momentum, M is mass, V is velocity. Momentum has a unit of kilogram meter per second. Mass has a unit of kilogram, and velocity has a unit of meters per second. Over here, delta P, that's change in momentum, and delta V is change in velocity. They have the same units as over here. We also have J, which stands for impulse. Impulse has the same unit as momentum. So J is impulse, its unit is kilogram meters per second. F is force, the unit is newtons. T is time, the unit is seconds. So what I want to show you is that although these are our 4 basic equations, we can write them in multiple ways. For example, over here with momentum. Momentum can be written in 2 ways that I can think of. There might be more. Well, there definitely are more. But here's my 2 that I wanted to show you. So by putting subscripts F and O, I can have final and initial versions of this equation. So momentum is mass times velocity, but final momentum is mass times final velocity. Initial momentum is mass times initial velocity. So if our momentum is changing, this is a way that we can get momentums for 2 different moments in time. Let's see what else we got. Over on the second equation, we can expand it using the idea of what delta means. So delta is a change, and we can figure out that change by taking final minus initial. So I'm going to expand it out right here. Delta P equals M, V final minus V initial. So now this is still technically the same equation, but by writing it in this way, I'm just changing the letters that are there. So if I'm given initial and final velocity and I want to get delta P, I can use this equation. And we can also look at this, delta P. Delta P, a change in momentum, can just be written as P final minus P initial. Now I can do this all day. There's a bunch of different substitutions I can make. If you continue writing these and you come up with 2 more ways, I'll give you an extra credit point. Just put it with your homework. So if you can figure out 2 additional ways, I'm going to do 1 more here. And it's just a combination of these 2. So if I combine these 2, the fact that impulse is the same as delta P, I can replace this with delta P. So delta P is also F times delta T. Notice I dropped the arrow here. It's okay to drop your arrows on top of the letter. It's just a little reminder that sometimes that number is negative. I dropped it over here. You don't have to have them in there. I like to. But it's not super important. So once again, if you can come up with 2 new rewrites, I'll give you an extra credit point. There's a lot of different ways to write it, probably 20 different ways. So here's one of our 3 practice problems today. Follow along and write it down, and you'll be 1/3 done with your assignment. Here's what we have. In a performance test, each of 2 cars takes 9 seconds to accelerate from rest to 27 meters per second. Car A has a mass of 1,400, and car B has a mass of 1,900. Find the average force that acts on each car during the test. There's a lot of information here, and I think a good way to start is by taking inventory, by separating all your information and figuring out what to do with it. So we have 2 different cars. We're trying to figure out the average force for each one. So let's start with that. We've got car A. We're trying to find average force for car A. Remember that little flat line on top means average. Car B, once again, looking for average force. Let's see sentence by sentence here. Each of two cars takes 9 seconds. Well, there's time. It's going to take them 9 seconds to change their speed from 0, from rest means initial velocity is 0, to 27. So for both cars, it takes 9 seconds for them to go from 0 speed to 27 meters per second. So let's write those down for each car. T is 9.0 seconds. That's kind of our change in time. Time is a weird one where like the delta doesn't have to always be there. The initial is 0, the initial is 0. I'm gonna keep going with this one. So like we said, V final is 27. So there's what we got so far. Time is 9, the initial is 0, V final is 27. Let's go back to our problem once more. Car A has a mass of 1,400, car B has a mass of 1,900. So that kind of gives us all the information we need to solve the problem. So M for A is 1,400, M for B is 1,900. Based on what I wrote down before, there are two equations that have F in them. Oh, that's not what we wrote down before. That's my old paper. I think it'll be confusing to use that one. I think this one right here. So there are two equations that we wrote down just now that have force. We got this one, and we got this one. It would be nice if they gave us impulse right off the bat, but they didn't. So what we got to do is go and try to find change in momentum based on what we're given. For each car, we have initial velocity, final velocity, and mass. Is that right? Initial velocity, final velocity, and mass. We also have time. Oh, but you know what? The time is going to be used here. So let's look over here, see if we can figure out change in momentum. Well, these all have change in momentum. See if you can figure out which one is best right now. I think we could use either one of these. I'm gonna go with this one. So let's try it. We're gonna get delta P for each of these. So delta P for A is gonna be M V final minus V initial. Delta P for B is M V final minus V initial. Now, we're going to use this equation on both cars. The only difference for each of these cars is their mass. They're going to have a different mass. So delta PA is 1,400 times 27 minus 0. Delta PB is 1,900 times 27 minus 0. And we'll type those in the calculator. So delta PA, we're gonna get 37800. Delta PB equals 51300. And the unit for these is kilogram meter per second. I'm not gonna write down the unit because it's not my final answer. Remember what we're really looking for. The problem says, find the average force. And so that's what that equation that I talked about a moment ago was all about. Average force is in this equation. Oh, sometimes I drop the delta on the t. It's not super important, so it's okay to drop it. Anyway, from this point, it's pretty easy to solve. This number goes straight in for delta p, and time is 9 seconds. That was given to us earlier on. So this number will go here, and that one will be 9 seconds. So we're pretty much solving them in the same way as one another. It's just different values for delta p. So this will be 37800 equals average force times 9. We'll divide both sides by 9 to get our final answer for A. And that'll be 4,200 newtons. And we'll plug in 51,300 for this delta P. But it's still 9. The time for car B is still the same. And we'll divide both sides by 9. That was a little quick, so if there's any spot that I missed you, if you don't understand a leap that I took from one step to another, let me know. I'll happily explain it. At this point, if you're golden here, go ahead and move on to the next 2 problems. When you're done, send them to me on Remind or send them on email. Good luck.